National Electrical Code, or NEC, Section 422.16b states that ground fault circuit interrupter, or GFCI, protection is required for all fixed resistance heating equipment rated 120 volt single phase or 120/240 volts line to line where the branch circuit protection is greater than 20 amps. According to NEC Section 422.16a, all resistance heating equipment must be grounded. Given that the 240 volts alternating current resistance heating equipment in question has a branch circuit protection greater than 20 amps, it requires GFCI protection according to NEC Section 422.16b. The claim that a given amount of known leakage in the spirally wound heated hoses would cause nuisance trips is not an acceptable reason to omit GFCI protection. The NEC requires GFCI protection for safety purposes regardless of potential nuisance trips. Therefore, the NEC code requires GFCI protection for this 240 volts alternating current resistance heating application. Proper grounding is also required. The supplier should be required to provide GFCI protection for this equipment to comply with the applicable code requirements. In more detail, let's discuss the NEC requirements for resistance heating applications. Firstly, let's define resistance heating. Resistance heating is a process where electrical energy is converted into heat as electricity passes through a resistive element. This type of heating is commonly used in various industrial and commercial applications, including but not limited to ovens, furnaces, water heaters, and specialized heating equipment. Understanding the NEC requirements is crucial to ensure electrical safety and code compliance in such applications. The National Electrical Code, or NEC, serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazard. Several sections of the NEC address specific requirements for resistance heating equipment, focusing on grounding, overcurrent protection, and, most importantly, ground fault circuit interrupter protection. Grounding is a fundamental safety measure required by the NEC for all electrical equipment, including resistance heaters. Grounding ensures that non-current carrying metal parts of the equipment are connected to earth, providing a low impedance path for fault currents. This connection helps to quickly trip over current protection devices like circuit breakers or fuses in the event of a ground fault, minimizing the risk of electric shock. Section 422.16 of the NEC mandates that all resistance heating equipment must be grounded. This requirement applies regardless of the voltage or amperage rating of the equipment. Proper grounding is essential for personnel safety and equipment protection. Overcurrent protection is another critical aspect of electrical safety for resistance heating equipment. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive currents, which could result from overload or short circuits. These devices interrupt the flow of electricity when the current exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. The NEC specifies requirements for the selection and installation of overcurrent protection devices based on the ampacity of the conductors and the rating of the heating equipment. Proper coordination of overcurrent protection is essential to ensure that the devices operate correctly and provide adequate protection. Now let's talk about GFCI protection. GFCI protection is a vital safety measure designed to protect people from electric shock hazards. A ground fault occurs when there is an unintended electrical path between a current-carrying conductor and ground. This can happen if insulation fails or if someone comes into contact with a live wire. Ground fault circuit interrupters are designed to detect ground faults by monitoring the current balance between the ungrounded, or hot, conductor and the grounded, or neutral, conductor. If there is a difference in current, even as small as 5 mA, the GFCI will trip, interrupting the flow of electricity and preventing electric shock. Section 422.16b of the NEC specifically addresses GFCI protection for resistance heating equipment. It requires GFCI protection for all fixed resistance heating equipment rated 120 volts, single phase, or 120/240 volts, line to line, where the branch circuit protection is greater than 20 amps. This requirement aims to protect users from potential electric shock hazards associated with resistance heating equipment installed in residential, commercial, and industrial locations. Now let's get into the specifics of 240 volts alternating current resistance heating equipment. As mentioned earlier, if the 240 volts alternating current resistance heating equipment in question has a branch circuit protection greater than 20 amps, it requires GFCI protection according to NEC section 422.16b. This requirement applies regardless of the equipment's application or the presence of any known leakage current. It's essential to understand that the NEC prioritizes safety and requires GFCI protection to minimize the risk of electric shock. Now let's discuss the supplier's claim regarding nuisance tripping. The suppliers claim that a given amount of known leakage in the spirally wound heated hoses would cause nuisance trips is not an acceptable reason to omit GFCI protection. While it's true that some resistance heating equipment may exhibit small leakage currents due to insulation characteristics, the NEC requires GFCI protection for safety purposes, regardless of potential nuisance trips. The NEC recognizes that GFCI protection can sometimes result in nuisance tripping due to normal leakage currents or other factors. However, the benefits of GFCI protection in preventing electric shock outweigh the inconvenience of occasional nuisance trips. In cases where nuisance tripping is a persistent issue, it may be necessary to investigate the cause of the leakage current and take appropriate measures to mitigate it. This may involve improving insulation, replacing faulty components, or using specialized GFCI devices designed to reduce nuisance tripping. There are ways around it. It is important to note that while the NEC requires GFCI protection for certain resistance heating equipment, it also provides exceptions in specific situations. For example, the NEC may permit the omission of GFCI protection for resistance heating equipment used in industrial establishments where qualified personnel are present to monitor and maintain the equipment. However, such exceptions are subject to strict conditions and require approval from the authority having jurisdiction. To summarize, the NEC code requires GFCI protection for this 240 volts alternating current resistance heating application. Proper grounding is also required. The supplier should be required to provide GFCI protection for this equipment to comply with the applicable code requirements. In conclusion, compliance with the NEC requirements for resistance heating equipment is essential to ensure electrical safety and code compliance. Proper grounding, overcurrent protection, and GFCI protection are all vital components of a safe electrical system for resistance heating applications. While nuisance tripping may be a concern in some cases, it should not be used as a reason to omit GFCI protection. The NEC prioritizes safety and requires GFCI protection to minimize the risk of electric shock, even if it means dealing with occasional nuisance trips. Therefore, it's crucial to adhere to the NEC requirements and consult with qualified electrical professionals to ensure that resistance heating equipment is installed and maintained safely and correctly. Always prioritize safety and consult the latest edition of the NEC for specific requirements and guidelines. By following these recommendations, you can help prevent electrical accidents and ensure the safety of personnel and property. The NEC guidelines are not just recommendations, they are the standard for safety and should be taken with great seriousness. The NEC is updated on a 3-year cycle, and it's important to always be referencing the most up-to-date information. Remember also that the authority having jurisdiction or AHJ may have additional requirements, so be sure to check with them too. In addition, grounding requirements may vary. Grounding is crucial for safety. Grounding resistance heating equipment means connecting all non-current carrying metal parts to the earth. This includes the metal enclosure, frame, and any other conductive components that are not intended to carry electricity under normal operating conditions. The purpose of grounding is to provide a low impedance path for fault currents to flow back to the source in the event of an insulation failure or other fault condition. This low impedance path helps to quickly trip over current protection devices, such as circuit breakers or fuses, thereby minimizing the risk of electric shock and equipment damage. The NEC specifies detailed requirements for grounding electrical systems and equipment, including the size and type of grounding conductors, the methods of connecting grounding electrodes, and the bonding of metal components. These requirements are designed to ensure that the grounding system is effective in providing a safe and reliable path for fault currents. Proper grounding is essential for personnel safety and equipment protection. It helps to prevent electric shock hazards by ensuring that exposed metal parts are maintained at or near ground potential. It also helps to protect equipment from damage by quickly clearing fault currents and preventing voltage surges. Furthermore, grounding helps to reduce the risk of fire by minimizing the potential for arcing and sparking in the event of a fault condition. Now let's get into some common misconceptions. There are several common misconceptions about NEC requirements for resistance heating equipment that can lead to confusion and non-compliance. One common misconception is that GFCI protection is not required for resistance heating equipment operating at voltages higher than 120 volts alternating current. As discussed earlier, the NEC requires GFCI protection for all fixed resistance heating equipment rated 120 volts single phase or 120/240 volts line to line, where the branch circuit protection is greater than 20 amps. This requirement applies regardless of the equipment's application or the presence of any known leakage current. Another misconception is that grounding is not necessary for resistance heating equipment if it is double insulated or isolated from ground. While double insulation and isolation can provide a degree of protection against electric shock, they do not eliminate the need for grounding. The NEC requires grounding for all electrical equipment, including resistance heating equipment, to provide a low impedance path for fault currents and to minimize the risk of electric shock. A third misconception is that nuisance tripping of GFCI devices is an acceptable reason to omit GFCI protection. While nuisance tripping can be a concern in some cases, it should not be used as a reason to bypass the NEC requirements for GFCI protection. The NEC prioritizes safety and requires GFCI protection to minimize the risk of electric shock, even if it means dealing with occasional nuisance trips. In conclusion, understanding and following the NEC requirements for resistance heating equipment is crucial for ensuring electrical safety and code compliance. Proper grounding, overcurrent protection, and GFCI protection are all essential components of a safe electrical system for resistance heating applications. Do not make the mistake of skipping any of them.